So good afternoon, everyone. You're very welcome to the CitA Tech Live Series 2021. My name is Alan Hoare from TU Dublin. I'm just representing the host today. I'm not the chair this afternoon. We're very fortunate to have Dr. Thomas Bock from Germany who will be chairing the event. Just a quick reflection on what we've looked at in 2021. We've looked at cloud-based construction management. We've looked at the cultural shift towards BIM, sensor technology, IoT, drone technology, digital twins, and e-commerce. So today is about construction robotics. And as we move towards the end of this year, we're looking at VR, AR, 3D printing, and blockchain. So all, I suppose, of what we look at as the top 10 technologies that will, we believe, transform the construction industry as we know it. So Shannon, could you go to slide 2, please? So there is our program for this afternoon. And you see, we're very fortunate to have such a great lineup of speakers. Thomas Bock, probably one of the global leaders in the world of construction robotics. And we've got speakers from Germany, from the UK, and from Spain. So looking forward for Thomas to introduce those in a minute. So on to the third slide, please. So this is what I would see as a fringe benefit to the CitA BIM gathering. As I say, Thomas will be speaking next Wednesday on the topic, where he'll be able to elaborate more. So we would encourage you all to register for the BIM gathering because we've got, up to 60 presentations over 3 days. I know everyone is very busy and we're emerging from the pandemic, but these are very carefully chosen experts looking at construction innovations that will impact on future generations in our industry. So we very much hope that you can make it to our event next week. Next slide, please, Shannon. So to book, there's a link there and you can contact Samantha on the email below. And we've got member rates, non-member rates, and group rates. So again, this is the 5th gathering that we've had since 2013, and we're looking forward to your support. So next slide, please. Also, we'd like to thank all our sponsors for the gathering, and they'll all get an opportunity to speak about the technologies that I just mentioned earlier today and many more. Next slide, please, Shannon. So thank you very much. I'm going to turn off my camera and my mic now and just enjoy the next 40 minutes or so. So over to you, Thomas, and you're very welcome.
Okay. Okay, thanks, Alan, for the introduction. And yeah, it's my pleasure to introduce you to this workshop. And we just changed a little bit the sequence. So actually, it's Mr. Kuchukov talking first about his LIFTBOT, and he was one of my former students in Munich, and then after him we will have Mr. Woods from Midland Steel, and then Mr. Max from Barcelona, and then we can have a short Q&A later. So I'm going to give a little introduction, a little bit an overview. There will be more, as Alan mentioned, next week at the gathering. And of course, industrialization prefabrication, that's what started about 5 decades ago. That's already state of the art, and we are quite advanced, having factories that can produce 50,000 houses a year. It's not mass production anymore. It's customized production, but everything is automated. This is one of the most automated factories in Japan and maybe worldwide. They produce about 50,000 houses a year in steel. I think it's quite interesting for what Mr. Woods will show, because they also want to do something in steel. And the assembly, I was also involved in the 80s. Rapid on-site assembly in 4 hours. We assembled a house in 150 square meter, 2 stores, and kitchen, everything already equipped. So high prefabrication ratio. Then the next step was to close the loop to the construction site, since most of the things go wrong on site, as you can see at the Berlin airport and other disastrous sites. It doesn't help if you do the nice prefabrication module and then you screw it up on site. These were the first 50 construction robots developed. I was part of them during my doctorate at the University of Tokyo. It's now we gathered about 300 robots in the Cambridge University Press series, 5 volumes. I'm going to show more details next week as well here. And recently we did a lot of the refurbishment renovation robots because that's a big challenge. And now robotics becomes more flexible and more adjustable. Also I will show next week a little bit more on it. We did 8 cable driven parallel robot, the first one in the world to assemble this facade in Spain, a site near Madrid. The robot inside the cage, the yellow cage, was built in my laboratory by my assistant, Dr. Iturralde. And this was actually my vision about 37 years ago. And I couldn't speak the language when I moved to Japan. And so I did some sketch, some comics, and actually it happened. Everybody was laughing in the beginning, but it happened. And I was also involved in this first automated construction site. It's like a vertical shipyard, and we developed all the machinery, and I did the robot-oriented design, joining the high-rise faster than conventionally possible. And this was applied to many, many construction sites by different companies. And this is part of my work I did for the company. So the robot could assemble the columns. And we just talked about MEP with Alan. MEPs are already prefabricated, shipped all around the Europe from Ireland. We did the same thing, and we assembled also by robots on site all the installations. And this was one of the recent sites I was involved in Osaka and Yokohama. But then came the virus, you know. Okay, and the next thing is the deconstruction. It's not dusty, there's no implosion, no wrecking ball. And we did it systematically. Actually, we went into reverse of the robotic construction. We did the robotic deconstruction of this high rise, so many high rises. You could recycle 93% of the whole high rise. Here are some examples. Actually, the lower one is across the Imperial Palace in Tokyo, so they didn't want to disturb the royal family. So very quiet, very clean deconstruction site. There is another one in Tokyo where it's very crowded. You can never use wrecking ball, and you can never use dreaming of using implosion. This would be forbidden in Tokyo. Anyhow, and then also civil engineering infrastructure is a big thing. Here I was involved as well on some new robots for huge underground storage construction, for huge underground caverns, automated tunneling under the Tokyo Bay, and the robotic assembly of the tunnel segments, and then of course controlling several robots at the same time. And I was 8 years as well with the civil engineers in University of Karlsruhe. We developed the first European road robot, as you can see here. And now I'm in Munich with the architects, but actually you have to combine all of this. And here's one of the most advanced autonomous robotic fleets after volcano eruption or tsunami or landslide in Japan, the different disasters. And I also was involved in these. So whenever it's dangerous, they send in the autonomous construction machinery next to the volcano or landslide. And well, that's maybe the vision of the future.
Okay. Yeah, we're just under. Do you have many more slides, Thomas, just there?
No, that's over. Maybe next step is space construction.
Yeah.
Okay.
Okay.
Anybody who want to get into more, they can check the Cambridge University Press books. There are about 300 systems described. Anyhow, more next week.
Okay.
So well, now we can talk about the first presentation by Artem.
I think we're going to have Tony first because
Tony first.
Yeah,
okay.
Tony. Tony, can you come in? Yeah.
Alan, thanks very much for the invite. Thomas, that's a very, very extremely impressive CV that you have there and what you've shared with us there in terms of process that you've done. We're a long way behind that as a company, but we have taken the first steps in terms of bringing robotics to our business. We are, I suppose, the first company in the Western world to adapt and bring a robot into our facility to replace work hazard environments primarily. So we started with that. A little bit about ourselves. So as a company, we are in 4 locations. We founded the business back in 1999, and rebar fabrication and offsite BIM process to include robotics is a big part of our future. So the services we provide are on the screen. We provide prefabrication, 3D modeling, BIM, cut and bend, mesh couplers and rebar. And we have a capacity of around 250,000 tons annually. So as a steel reinforcement fabricator, our services are including the following. We have more or less converted our mindset from manual fabrication to try and go down the route in all aspects of our business, and to encourage new talent to our business by utilizing the robotic process. And when we first purchased our first robot, I'll show you in a moment what it does and how it's assisting us in our business. We found the benefits that it was giving us were far in excess of what we were currently doing in, we'll say, a traditional sense. So we have a situation here, which is our case study. What you see is an automatic machine, very manual operative process, and there were some hazards with the machine. There's a guard over the current head of the machine, as you can see there, to protect the operator. But we believed that there was a better way and a better process. So on attendance of a trade show back in 2017, we looked at safety with a particular supplier. We looked at production optimization, and we looked at the operator. And we looked at a robotic process. How can we bring a robotic process to our business? And how will it benefit us and the future of our productivity and make it a safer working environment? The other consideration we had for this process was primarily the application of trying to bring new talent to our industry. Our industry is previously traditionally known as a very kind of manual operative process, not the cleanest environment, as you're handling steel all the time. So by combining our expertise in what we do and the robotics engineering company whom we use to supply as our first robot, we came up with this. And what you see here is now the robot assisting the machine. The machine is operating on an automatic cycle. The robot is doing all the manual handling and all the manual work that was previously done by an operator. And that now is a benefit from our point of view in 2 ways. Firstly, from a health and safety point of view, it's enormously beneficial. Secondly, the precise accuracy of the way the material is being stacked in the sack material that you can see placing in it is far different to what a manual operator will do. So it's way easier when it gets to site to take the material back out again of the sacks. And we've had our customers complimenting us on that particular item. So when we got this robot, we started to acknowledge and decide, well, what can we do next? And part of our process and configuration of reinforcement is in an offsite environment. Our next step is to take it to the BIM process, which we detail the modular sections. The modular sections are an enormous benefit on site, but before bringing them to site, we have got to come up with a robotic manufacturing process. And what you're seeing here is a simulation of our idea. We haven't got there yet. We're very, very much in the infancy part of this process, but we are developing a machine to automatically weld reinforcement material with robots. What we're achieving from that is, and why we believe the manufacturing sector needs robotics, is firstly, we're currently traditionally doing a lot of exhausting work tasks, tying and welding of rebar. The average age of the operators is steadily increasing, and it's now the average age of a manual operative in our industry is around 44. Welding is a very boring, hot and manual process. There are very few young people who are choosing this as their future careers. And what we are trying to do, I suppose, is initiate the robotic process and now employ robotic technicians. And that will be, I believe, the future generation of people that will become part of industry compared to the generation of people who are now, we'll say, currently working a manual, very, very manual operative process. The industry is not going to change. Future talent want to work with digital and automated solutions, and it's up to us as a supply chain to make these jobs available. The industry, as I said, will not change itself, but it can be influenced by the supply chain that attracts new talent to the things differently and more modern methods of construction, all the while keeping people engaged and bringing new talent to the business. What that will achieve: offsite manufacturing using robotics with production efficiency, improves the work environment in health and safety, which is our #1 priority. It gives the operators rewarding jobs, and we can upskill our current operators to become those robotic technicians and employing more on the mechanical and electrical side in terms of maintenance. And obviously at the end, that will bring, with automation, a good cost saving to our business and a good commercial offering then to our customers. So that's where we are as a business. We're, as I said, started with 1. We're now looking at adding and developing the machine for phase 2. And we believe in 10 years' time that without robotics, our industry will certainly be in an enormous bad way unless we can automate and digitalize our full process. The digitalization is as important as the robotics, as they're all linked. And that's where we see ourselves going as a company. So thank you for the time for me to be able to demonstrate this for you. And Alan, I'll hand it back to you.
Yeah, and just to say, Tony, that would be the perfect message next week. And as it happens, you have a very busy diary, I know that, but as it happens, a slot has come up, what I'll email you about after this, on Friday morning at 9 o'clock, for you to just to have a little bit more time to give people, I mean, that message, you know, construction innovations for future generations, the future of, you know, reinforcement manufacturing will be largely automated, I suspect.
100%.
100%. So if you could find 15 minutes next Thursday morning for us, we'd love to have you at the gathering to give an address.
Okay, I'll do all I can to be there.
Thank you very much. I don't know if there's any questions. I know you're a busy man. Thomas, have you any questions maybe for Tony before he leaves?
I think it's very important what he's doing, what Tony is doing, because I see a big potential, as we discussed before this meeting, that this will be the next step where you have the components like Midland is producing, and they will be more and more automated and as a supplier to the construction side, and they take a lots of relief from the on-site construction. So I see a big potential in the work of Tony's company, and also have to think about more and more services in this direction, adding other functions and so on. So I think it's the right way they are doing there. So congratulations to Tony. Yeah.
Thank
well
you,
done, Tony. You probably have to run now. Good luck in your meeting.
Yeah. Okay, thanks very much for that. Yeah.
And I'll flick you an email later on.
That's fine. Yeah, 100%. Sorry, I'm just under some pressure today, but
no problem, and we appreciate it.
No worries. Thank
genuinely.
you.
And and
so
Artem, thank you. I'll hand you over to Artem now, and back to Thomas, who'll introduce our next speaker. Thanks, Artem, for your patience.
Yeah, it's good. It's good to see Mr. Kuchukov again. So he did his studies in the Master of Advanced Construction Building Technology, and then he started his own company, and for scaffolding, and because any kind of building needs scaffolding. So I think this company will have a big potential in the future. So looking forward to Artem's presentation. So please go ahead.
Okay. Thanks, Professor Bock. Great to be able to present what we're doing, and yeah, just I'll just jump right away to just giving you a short idea on where we are and what we're doing. So I just shared with you my screen. Let me know if there are any problems. Just generally, just to give you a short idea, as Professor Bock mentioned, we have started working on KEWAZO after doing after graduating from masters and construction robotics at TU Munich. It was 2016. Still studying there, and so like 5 years ago. So later on, 2 years later, we have founded the company in 2018, and the company is still based in Munich. Currently, we are 25 people. We are supported by leading investors from Germany and Silicon Valley, with the goal of digitizing construction with robotics and data. And as Professor Bock correctly mentioned, our first focus is scaffolding assembly. Scaffolding is just one of those areas where which struggles today from problems of safety, labor shortage, and inefficiency. So a lot of projects in scaffolding are still done completely manually, up to 80% of projects actually, with just a human chain of 10, 11 people standing above each other. And this is, of course, not the most efficient way of doing this, right? But unfortunately, because all existing solutions are so hard to operate and it takes too much time to install them and too much overhead, people are still keep doing this completely manually. As a solution at KEWAZO, we provide the hardware and software solutions to address these problems. So on the hardware level, it's a robotic material hoist LIFTBOT, can be quickly deployed with just standard tools. It's completely it's wireless, so it's battery powered, and it can be installed in 20 minutes. Requires almost no space on site. And is build controlled also completely wirelessly. So you have remote controllers that help you to operate in automated mode. Because of this, what you end up having, so instead of having 10 or 11 people, jobs can be done just with 3 or 4. This way, saving up to 44% of man hours, or around €1,000 per day. Other than that, it's also a direct solution to the problem of labor shortage, because you don't need to have 10, you need to find 10 or 11 people for the project anymore. And it also improves safety because people get tired less and doing less accidents. Simultaneously, by having robots running outside, we gather operational data and we improve transparency of processes on site. And what we do, we gather such information as how much material is being transported, to which height, when this happens, and we deliver it back to our clients in the form of a cloud platform, where they just can see like a storyboard of their previous projects. Later on, we've also planned to analyze this data with the help of machine learning, so that we can derive patterns from their previous jobs. As the next step, we also plan to introduce computer vision. So we plan on be able scanning projects in also single parts, and this way to actually give our customers more transparency on what's happening on their sites. So our strategy in general is to bring robots on site and deliver our clients savings on man hours, improve safety, be able to also address the problem of labor shortage, but by having these people heavily interacting with robots to generate also additional digital services, which they don't have today, which they may not understand today, but we will deliver to them because they already have robots, right? So it's digital services enabled by via on-site robotics. So from the technological features, we have autonomous navigation and control. The solution is completely wireless, and we also provide, as I mentioned, data analytics services. Other than that, we also support, we have an after-sales support in terms of a remote maintenance and predictive maintenance for our clients. The solution is mainly deployed in 3 main areas: is construction, industry, such as oil and gas, refineries, and maritime. So between our first customers are such companies as Bilfinger, one of the leading industrial service providers in Europe. And what's important for us at scaffolders, so people who are on site actually like our solution and they want to work with this. The first reaction is, of course, people are really, really reluctant, really critical. But just 1 or 2 days after they work with LIFTBOT, they're pretty happy. Where we stay today, last year we certified LIFTBOT, and this year we already brought the first batch on the market of 5 systems. So we have systems running on different sites already since January this year. And here I just would like to show you just an example of how this works in practice. So here you see a project from 2019, like 2 years ago, but you can see a typical refinery setup, right? This is not where you are every day. So that's probably, you haven't seen this if you didn't go there with purpose. This is, like, as you see, is a lot of pipes and what's happening, because it's not a lot of space available. Usually what happens, scaffolders just stay with the human chains of 10 to 11 people and assemble it manually. But in our case, because LIFTBOT is completely wireless, doesn't require much space, we can install it even in complex situations. So what happened here, here we are on a 30 meters high platform, and we need to build the last 30 meters of the 60-meter high tower. So normally you would have 4 people assembling this scaffolding in 4 days completely manually. But because LIFTBOT is easy to carry with hands, it's completely wireless, doesn't require much space on site, this could be deployed here, and 3 people assemble the scaffolding in 3 days. Right, so you can see here how it operates. Once material is loaded, scaffolder just presses a button, and the system automatically drives to the required height with a speed of 42 meters per minute. So what you see here, it's a pre-series version. It's a version 1.0, which we had 2 years ago. And but even here, we could already see that we can deliver high efficiency gains. And this is why we went further and delivered a certified product. Right? So this was certified last year. And here you can see it's a Meyerwerft, one of the largest shipbuilding yards in Germany, where you already see next version of LIFTBOT, which is certified and already produced in a small series at our clients, Bock and Deconstruction. So they have 100 scaffolders every day, all year round, and they have a framework contract with Meyerwerft for the next 3 years. So they know, in fact, that they will have those scaffolders, like 100 scaffolders for the next 3 years, and they will have a lot of those scaffolding projects. 8 of them are assembled completely manually. So what happens, they decided to go with LIFTBOT. They deploy it since January already, and every day when they deploy LIFTBOT, they save at least 2 workers, which can be deployed on other projects. Our client, Bock and Deconstruction, also see a lot of advantages in data analytics solutions. So they're able to track projects, how they develop, and what's happening on site. So for them, it's a big advantage. And generally, LIFTBOT, like scaffolding, is just our first application area. We also plan to deploy it for installation, transport, equipment transport, and general material transport at construction sites and refineries. So this is something that will be tackled as the next step. And yeah, thanks for your attention. I'm open to your questions.
Yeah, fantastic product. I mean, I can only see this product becoming more and more successful as you add additional benefits. But the shipping industry, I mean, they're building, so you can see that they would employ lots of scaffolders. What do you think, Thomas, of your student?
Sure. I mean,
very successful.
Yes, and this is exactly the way to go, because you have to first to adjust to the existing system, and then you have to trigger this metamorphosis of the different subsystems, and this is always what we teach. We bring examples from other industries: aircraft industry, shipbuilding industry, space industry, and so on. So that's the way to go, and where you can apply it. So it's not only limited to construction, but also to other industries like Artem showed, shipbuilding, and and many more, even infrastructure and so on. So I think this is a big potential.
Yeah, I think Artem is probably needed to get away. I know it's probably a sentiment of where the world is at the moment. Everyone is running so fast, they don't know how to stop and just think. But Artem, thank you for accommodating us.
Thank you.
Tony
Thank
got
you.
in ahead of
Talk
you
to you
with the
later.
request, so sorry we couldn't accommodate you earlier. Thank you so much, and take care.
No worries, thank you.
We'll keep in touch with you. Okay. Thank you.
Definitely.
Definitely.
Great to be part of it. Thank you.
Yeah.
Bye-bye.
So Thomas, I'll hand you over now to Stuart.
Yes. Now it's my pleasure to announce Stuart. He works for a company in Spain, and I had a nice construction site in Barcelona once. So it's a beautiful town, and also a high-tech area, Catalonia and Barcelona. They are one of the most advanced technological advanced areas in Spain. So I'm looking forward to his presentation. So please go ahead.
Thank you very much. Thank you very much for the introduction. And also a pleasure to see you again. I have to admit, I do have one of Thomas's books in my library in the office that we do try and ram down the throats of people that are joining the company. It's a pleasure to be here. So what I would like to talk to you about, and I'll share my screen in just a second, is an introduction to the company, which is Scale Robotics, a little bit about myself, why we've kind of taken a couple of the decisions that we've made to be able to build the product that we're building today, but then also kind of hinting at what the future, what we think the future will be around that. And I'll even be bold enough to do a live product demo, which I'm sure won't go completely wrong. So let me just share my screen. Oh. So my name is Stuart. I'm the CEO and co-founder of Scale Robotics. And we are a Barcelona-based company that is automating the comparison of reality to the plant. And we believe that this is a game changer for construction. We think that by connecting the physical world, physical workflows with digital workflows, then we have the opportunity to bridge that gap and supply better information to make better decisions to be able to de-risk project delivery. And we can take billions or trillions of dollars of assets and we can build them faster, better, more efficiently, reducing waste and reducing uncertainty on project delivery. And I think the best place to kind of understand what we're doing and why we're doing it is if we go to Oslo and we talk about a project that we did there. So this was quite a while ago now, but this was the depths of winter, absolutely miserable, at least -10. And they were trying to build a 30,000 square meter development right down by the waterfront. And it was plus or minus 10 millimeters of structural steel and concrete, which to me sounds incredibly ambitious, but this is what the project needed. So plus or minus 10 mil of structural steel and concrete. Now, the problem is that on this site, a structural wall was brought to the attention of site management, and it was not 10 millimeters out of place, it was actually 10 centimeters out of place. Now, if this had been left undiscovered, it would have cost thousands of euros in extra costs. It would have cost the valuable time of at least 8 site managers running around like headless chickens trying to work out what was going on. And it would have cost at least 1 week of schedule delays on this project. And the crazy thing about construction is that these kinds of issues are basically the cost of doing business. This is what we consider normal in construction. I think this is what we're all fighting against. But what was not normal about this particular project, and why it has a special place in my heart, is that this issue was automatically flagged up to site management by our AI-powered software platform so that this issue could get fixed at no extra cost while the subcontractor was still on site. Better information to make better decisions to be able to de-risk this project. Now, why did this even happen in the first place? In our minds, what it comes down to is the fact that whilst we're designing digitally, we're still constructing manually. So we put a huge amount of time and energy into the design phase, into BIM, a huge amount of investment in BIM. And yet, when you get to the field, there is a person there with a tape measure and a bit of string, basically putting things wherever they feel like that day. And someone described to me that modern construction that we have at the moment is everyone building their hangover into your building eventually. And I think this is a little bit unfair because I don't think people come to work wanting to do a bad job. But construction is incredibly complex. We're talking about the installation of hundreds of thousands of elements in time and space by probably hundreds of different stakeholders in the elements. I mean, you saw -10 in Oslo. It is incredibly difficult to be able to manage this project and to be able to deliver to the quality that we know that we need to be achieving within the industry to meet all of the targets that we have in terms of environment, in terms of quality, in terms of the product that we're delivering to the end customer. So it strikes me that it's insane, completely insane, that there is no quick and easy way of comparing what you intended to build to what has actually been built in reality. So how do we solve this problem? We capture data on the construction site. And one of the ways that we do that is with this little robot that we have right here. We have a version. I'm actually just going to look down right next to me on the floor. We have one of the versions rolling around. But this is just one of the tools at our disposal to be able to capture data. We're also using handheld laser scanners and terrestrial laser scanners to be able to capture data. We're a business after all, and we need to have a broad funnel of information that we're capturing. But I'll get into that a little bit later, because either way, no matter whether that data is coming from a robot, a terrestrial scanner, a handheld scanner, it's going to start its life as a point cloud. And I think many of you have probably seen a point cloud before, but it's a huge amount of raw data that you're getting from the construction site, whether a terrestrial laser scanner, Boston Dynamics dog, doesn't matter. Huge amount of raw data full of clutter and noise and chaos, very complex environments for a robot to operate in, but also to extract any useful information. So what we do is we upload all of that data into our software platform, and we start to process it using computer vision and machine learning algorithms. And this is a project that we worked on in the UAE. It's an indoor roller coaster, because that's the kind of thing they build in the UAE. But it's incredibly complex. And Artem would have loved this because it was full of scaffolding. But it's probably more scaffolding than actual building. And we have to start to make sense of that reality to be able to make decisions. So the first thing that the software is doing is it's just coming in and it's filtering out everything that is not the building. So everything that turned red is not the building. And we filter all of that out so that we're left with good data. And it's really as simple as good data in, good data out. Filter it, start to understand it, and then we try and take something incredibly complex and we try and make it as simple and as intuitive to understand as possible. So we align the BIM with the raw data, and we run an analysis on every single element and try and make something complex as simple as possible. So we just color code everything within the model to be able to give you a rough analysis. So everything gray means no data, not enough information to make an assessment. It means that we haven't seen it or seen enough of it to tell you anything useful. Everything green is within tolerance, so it's been built correctly. That's good. You should be happy with that. Everything red is missing and has not been installed. It doesn't mean we haven't seen it. It means it hasn't been installed. And then everything orange is out of tolerance and has not been built correctly. Now, the problem with construction is that when you run through, everything is orange, everything is out of tolerance, and the entire building is technically wrong. But there's a big difference between technically out of tolerance and wrong, and this is genuinely causing me a problem on my project, and I need to be able to take some kind of action. So what we do to cut through the sea of orange is to be able to make this information searchable. So I can come in and I can search through all of those elements, and I can find out that this element right in the middle, this wall, is actually 10 centimeters too close to that central core, which means that the pipes and services are not going to fit from behind, which then in turn means that you would have to take expensive action to be able to mitigate that problem. And the fact that we picked this issue up as it happened means that the cost of fixing that issue and keeping the project on track and on critical path is going to be a lot cheaper. So you're immediately wiping out 10K of cost just with one issue. Now, what does that look like on a real construction site? I'm going to be brave and I'm going to share my screen and show you what that looks like on a real project. I'm going to assume that you can see my screen, and you should be looking at this hotel project in Oslo. Everything's hosted in a web viewer, so we're taking all that information and we're packaging it up and we're giving it to you in a format that anyone, no matter where you are, from Japan to Munich to Dublin to Barcelona, everyone has access to the same high quality information. And I can see all that color coding, and there is actually 2,440 elements that have been automatically classified. This is too much for a human being to be able to understand. So what I do is I can filter and manipulate and search for that information. And I can say, you know what, only show me elements above 25 millimeters of deviation. That reduces my search space from 2,440 to 15. Then I go into my list. Everything is automatically ranked by the magnitude of deviation. So I double click here. I have my wall. It's telling me it's 10 centimeters away from where it needs to be. I'm going to visualize that by checking out what it looks like on site. This might be familiar to you from previous slides. Every single element is automatically tagged with every 360 image that it appears in. So I don't have to go searching for information. It's already been pre-organized. And then I can actually highlight it within the image to know exactly what I'm looking at. And it means that I'm using machine learning, spatial intelligence to be able to make better decisions and organize that information. I can visualize the deviation using a heat map, which now means that I can see if red is negative material, then I can see that there's negative 100 millimeters of material underneath that doorway. We understand that for all the robots and machine learning tools out there, it's an industry that still enjoys 2D drawings. So we automatically generate 2D section drawings of every single element so that you don't have to then make it yourself. We're communicating in the language that people on site understand to be able to deliver that information back. And I can just measure that out. Black being the BIM, red is reality. There's about 9.5, 10 centimeters of missing material underneath that door. So what I'm really trying to get across here is that we've gone from having no information about our project to having a really fine-grained understanding of what is actually happening using the tools and technologies we need to be able to understand large quantities of very complex construction data. The same technology that you would be using to navigate a site and the same technology you would need to be able to start actually making decisions about what you want to do on construction sites. Final point to be kind of making, I think at this point, the way that we're looking at construction is we're kind of like wandering around this desert and we see these kind of patterns of rocks in the ground, and we see little fragments of this big picture. And we look around and all we can see are these fragments. All we can see is what we perceive ourselves, because we're only human after all, and we have our finite experiences, and we have a finite amount of things that we can take in. But what machine learning is doing, what robotics is doing, it's allowing us to capture information and look at it in a different way. So it gives us a different perspective on the projects that we're running. So now, when we look at this same pattern of rocks on the ground, but we look at it from the air, we realize that it actually forms the pattern of this incredible bird in the middle of the desert. And it's the same with construction. When we look at it from a different point of view and a different perspective, we start to realize that there are patterns going on under the surface that we would never have been able to pick out as a human being. And we're using better information, better insight to make better decisions, to be able to de-risk projects and to be able to move towards the future of a fully automated construction site, closer to what we would call true automation, or building products in the same way we're building iPhones in factories. High quality, better information to make better decisions. Thank you very much for your time. Really a pleasure to be here. If anyone has any questions, my email is on the slide, and always happy to answer any questions. Thank you very much.
Thanks, Stuart. Interesting.
Thank you very much. This is a pretty good, also again, pretty good selected from Alan, all these presentations, and actually very important what Stuart is doing. And it's what I mentioned, like we have recently very catastrophic construction sites in Germany. You heard about it, Elbphilharmonie in Hamburg, Berlin Airport, the underground, the new train station in Stuttgart, going to be 4 years delayed, 3 times cost overrun, and stuff like this. So it's awful. So actually, this is very important, and the next step must be that we link these data to do it right at the first time, you know. So, but first you have to do what he's doing now, and then later, next step is to do it right at the first time. So control the process proactively. But first you need to do what he's doing. I think is a high potential company as well. Thanks, Stuart, for the nice presentation.
Yeah, it's really interesting. We have a few projects like that in Ireland as well, where we had problems. The problem with a lot of these projects is they're so big, so large, so complicated, and they try to maybe look at things traditionally, whilst really they've got to. You can't eat an elephant. You've got to take each component and work your way through. So it seems to me that the people that are behind these large projects that are responsible for delivering very large scale infrastructure projects, by way of an example, they need the best technology in position as a default position. You know, the not to be thinking to believe in the contractor. It needs to be driven from the client right through. That we want scale robotics. We want innovation in all our packages, like what the previous speaker was talking about. It just absolutely makes sense for scaffolding. It's safer, it's more efficient, it's cost productive. Everything is good about this new way of working. So I think we've got a good insight. I think this topic, Thomas, we're going to try and stay with this a little bit next year. I know you're a very, very busy man, but and thank you, Stuart. I know Tony and Artem had to leave, but I think you'll get more of an insight on Wednesday at the gathering. But I think we're going to come back to this, particularly companies like Artem and Stuart. You know, new companies spinning out, creating new products, and getting behind those companies, because it's great to see it. You know, Michael O'Brien might have a question. Have you, Michael?
Yes, Alan, I'm involved with Midland Steel, and I've been involved in the offsite side of things as well, and looking at it. And a comment I'd like to make, and listening to what everybody says, is that people and clients and contractors often don't understand the process. Because what we're bringing a lot of times with our innovation is a new process and a new way of thinking. And part of ours is to showcase our products, absolutely, and to showcase what we do and how we do it. But getting people and getting that message across where they understand that, you know, how we're doing and how our process works. And I think when we start to win that battle as well, and it's slowly changing, and it is changing, and it's very much a job by job basis. So you look at it, people look at projects singularly, rather than the whole construction industry objectively. And that leads to sometimes you have projects and it's hugely successful. And then within companies, it doesn't kind of filter through, and they're not bringing it in to everybody. Look, we have to look at this in its entirety rather than in a singular way. So just a little comment, everybody. I mean, we're totally on board. We see it. We see the future. Yeah. It's where our future, and it's where the construction has to go to. But just a comment on the process.
It's interesting because I get it, and I get it, and I you know, this needs to become kind of, I suppose, the norm in the future. What I was recently speaking to some BIM managers or BIM coordinators in around Ireland, and they were saying to me that they're now clients don't want this technology, and I'm just thinking, well, they shouldn't even have to know about it. You know, if you're employing an architect or an engineer, or they should just use this technology. The client just wants the building on time, in budget, to the quality, safely built. They would expect these companies to be using the best technologies. And so if a contractor is employing a scaffolding company, why not look at the solution we heard about earlier? You know, why not look at scale robotics as an option to, you know, to monitor the progress of your project using scanning technology? So it's just, it's inevitable. This is the way we're going.
Yeah, I think absolutely is inevitable, and people will see it. And I said it is turning. But another comment is sometimes yes, they want it, but do they want to pay for it?
That's the problem, you see, with the BIM guys are saying that they won't pay for it, but
yeah, they won't.
In the long term, it should be cheaper. Sorry, Thomas, you might want to comment there. The long term, it should save money.
Yeah, no, that's exactly what we discussed before with Alan, before we started here. I mentioned this Dutch company I advised for the medical center in Rotterdam, the client didn't want to pay for using this teleoperated, partially automated construction site of the 135-meter tall building for the medical center. And what the company did, they used it anyhow, and they finished a couple of weeks ahead of time, and then they used it at another site. So they made the profit. and I think this is the way to go. We have to think from behind. I mean, I tell always my students, because the problem is with the architects, I'm also civil engineer and architect, and later I got a robotics degree from Tokyo. So I'm mixing all these fields, and I can criticize anybody because I'm in three professions. So the architects have the problem, they design something and then later they calculate what it might cost and then how you can implement it, how can you build it, realize it. But you actually have to do it the other way around. You first have to think what the customer can afford, what is the return on investment you want to have, and then in the end you decide, you know. But this, of course, architects don't like to hear, and they would lynch me for this, but actually this is the most efficient way. And then you come up with a new process, just as Michael said it for Midland. We have to have this process thinking, and otherwise we cannot improve. But this is the first step for this gathering here next week, and I hope we can do more in the future next year and so on.
Yeah.
So I think it's very important, this process thinking from behind, from the end. And then, you know, it's a kind of reverse engineering, and then you go forward again. But first you have to start from the end.
They call that, is it inductive and deductive thinking? In other words, thinking the opposite way. Yeah. So I'm just conscious of the time, and also the fact that I have another meeting at 2 o'clock, so I need to have some lunch. And so I'd just like to thank you, Thomas and Stuart, in the absence of Artem and Tony as well, to thank them, the CitA team. You may know, Thomas and Stuart, that we're now emerging from the pandemic here in Ireland. I know there's lots of places around the world where they're maybe in a more precarious position, but because of the move towards returning to office or returning to normality, people's time is precious, and so we're finding this month in particular, hopefully they'll find time for us next week, but I think people are busy assembling their sites and getting people back to work and so on and so forth. So we probably hadn't as large an audience today, but this event has been recorded for prosperity, and it will go out on social media. I think people will enjoy listening and hopefully connecting with you in the future. So just to wish you every success, and to thank everyone and the CitA team for all the hard work, and hopefully we'll see some of you next week at the BIM gathering event.
Okay, thanks, Alan.
Thank you very much, guys. Thanks. Take care. Bye.
Bye. Bye.